Hi, hello, welcome to another math lesson. Today we're going to talk about polynomial operations, specifically adding, subtracting, and multiplying different polynomials together. Let's get started. So during this lesson, you're going to learn how to add two or more polynomials, subtract two or more polynomials, and multiply two or more polynomials together. Some vocabulary. We've gone over all these. Polynomial is a function or expression that consists of many terms. A monomial is a polynomial with just one term. A binomial is a polynomial with two terms. And a trinomial is a polynomial with three terms. So terms are numbers, variables, or numbers multiplied by variables and separated by addition and subtraction. So here's an example. I have 5x squared plus 3x minus 7. Notice each one of these is a term. So this is term 1, term 2, and term 3. So I have three terms. Notice they're separated by additions or subtraction signs, and that's how we divvy up our terms. Like terms are terms that have the exact same variable situation, meaning the variable have the same exponents. Closure under an operation means a number, system, or expression that when the operation is performed on those values or expression, the result will still be in that number, system, or expression. Distribution is multiplication of a polynomial. If you multiply a polynomial by a constant, that means the constant must multiply every term of the polynomial. Like this, 3 goes into 5 and then into 4, which gives me 15x plus 12. We have to distribute that. Adding polynomials is pretty basic. There's a lot of different ways we can state it. We have this f plus g, f of x plus g of x, f plus g of x, and then simply f plus g. So when adding functions, you simply combine the like terms. Let's do an example. So it says find f of x plus g of x. So I have 2x plus 7 plus what g of x is, which is x minus 5. Now I can simply group my like terms together here. There we go. All right. And then my constant terms plus 7 and minus 5 together. We get 2x plus x. We get 3x. And 7 minus 5 is plus 2. So I know f of x plus g of x equals 3x plus 2. All right, you give it a go. Pause the video, see what you can do. All right, so f of x is 5x plus 17 plus a negative 3x minus 5. So I have 5x and a negative 3x will combine. This is going to tell me what f of x plus g of x equals. That gives me a 2x. 17 minus 5 gives me plus 12. There is my answer. Now, subtracting polynomials is very similar, but we need to remember to distribute the subtraction operation. So it's very similar to the notation for adding polynomials. I have f minus g. I have f of x minus g of x, f minus g of x, and f minus g. Those are all ways that I can ask you to combine these. So notice here I have 2x minus 1 minus 3x plus 5. Okay, we need to remember to distribute that negative. A lot of the time, people will just distribute this negative to this one, and they forget about this guy back here. Okay, so we have to make sure to distribute to everything. So here's my example. Find f minus g of x. So I'm going to plug in my f term, my f of x term, which is 3x plus 7, minus, and I like to put parentheses when I'm using subtraction for my second term, x minus 5. That way I remember to distribute that negative sign. Okay, so that's what we're going to do next. I'm going to say 3x plus 7. Distribute that negative, so that gives me a minus x plus 5. Once I do that, it's just like adding them. I'm going to combine my like terms. 3x minus x gives me a 2x. 7 plus 5 gives me a plus 12. So I know f minus g of x equals 2x plus 12. And there's my answer. I want you to try on these two. There's a sum and a difference here. So the first one here, we're going to say 5x plus 3 plus 2x minus 5. We're just combining like terms. We get 7x minus 2. There's that answer. For this one over here, we have f of x minus g of x. So we get 5x plus 3 minus 2x minus 5. I'm then going to distribute that negative. So we get 5x plus 3 minus 2x plus 5. Okay, now we can combine like terms. 5x minus 2x is 3x, and 3 plus 5 gives me plus 8. One thing to watch for is make sure that you understand what this order is. If it said g of x minus f of x, I would start with g of x first and then subtract f of x from it. Alright, I want you to try again, just like this one. So g of x plus f of x. Order matters. So g of x equals x plus 4 plus my f of x, which is negative 3x plus 4. We combine our like terms. X plus a negative 3x gives me a negative 2x. 4 plus 4 plus 8. Beautiful. Okay. Now for this one, we have g of x minus f of x. So I'd say x plus 4 minus, there's that parentheses, f of x, negative 3x plus 4. I'm going to distribute that negative, so I get x plus 4 plus 3x minus 4. Combine like terms, we get 4x, and then those two cancel out. There's my answer. Okay, so not too bad. Adding, subtracting, we've kind of done before. We understand those things. Now this is where it gets complicated. When multiplying functions or polynomials, every term in the first group must be multiplied in everything in the second group. It's complicated just because you have multiple things that you're doing. It can be f times g, f of x times g of x, f times g of x, f times g, in parentheses. There's all these different kinds. The one thing to watch out for is if you see an open circle like this, that does not mean multiplication. Okay, has to be filled in to be multiplied. All right, so you can do FOIL distribution, which is okay as long as you have a binomial by a binomial, meaning a two-term thing multiplied by a two-term thing. Okay, so as long as you're doing that, you're okay. If two functions or polynomials both have only two terms, then we can use FOIL. Okay. I like to use the box method here just because it helps me to have everything distributed properly. So I have 3x plus 2 here and 2x minus 5. Now I can just fill in each of these. So in this first box right here, I'm going to take 3x multiplied by 2x, right? Which gives me 6x squared. And then for this second box, I'm going to have a positive 2 times 2x, which gives me 4x. This third box, I'm going to have 3x times a negative 5, which gives me a negative 15x. And then in this fourth box, I'm going to take 3x and multiply it by a negative 5, which gives me negative 15x. Now Now the cool thing about this is I can now get out my polynomial. So I get 6x squared. These diagonal boxes add up together. So that gives me a negative 11x. And I get negative 15x. Or negative 15. Oh, hold up. Where'd I get that 3x from? I messed up. I'm so sorry. In this box, I have In this box, I have 2 times negative 5, which gives me negative 10. This is partly why I like this, is because you have our like terms kind of all line up in a diagonal. So the answer to this is 6x squared minus 11x minus 10. It's a very simple way to keep things organized. Your like terms should line up in a diagonal, just like these do. Okay? If you have a like term that's not in a diagonal, you messed up just like I did. So I guess I could say I did that on purpose to help you guys out. Okay? Alright, now I want you to try. So this time, notice, I have a binomial being multiplied by a trinomial. We can still do like the box method for this. So what I'm going to do, instead of having a 2 by 2 box, we're going to make a rectangle here. And it's going to be a 3 by 2 box. So I'm going to put 2x squared plus 4x minus 5. And we get 3x minus 5. The same thing still happens. In this first box here, it's still 2x squared times this 3x, which gives me 6x to the third. And then I get 2x squared, and then this next box is 4x times 3x, which gives me 12x squared. Then this third box, we have negative 5 times 3x, gives me negative 15x. Now we can come back down to box 4 here. 2x squared minus 15x, or minus 5x, gives me a negative 10x squared. Box 5, 4x minus 5 gives me, or times a negative 5, gives me negative 20x. Negative 5 times negative 5 gives me a positive 25. And notice my diagonals are my like terms. We can add those up. So I'm going to get 6x to the third. My diagonals add up to be, so we have 6x to the third. Here I have 2x squared. Here I have negative 35x. And then we get 25. So I get 6x to the third plus 2x squared minus 35x plus 25. Okay. Whew, there's a lot of these, right? So let's make this happen. So f of x times g of x, okay, binomial by binomial. I'm just going to do a quick little box here. 2x plus 3, 3x minus 5. Okay, we get 6x squared, 9x, negative 15, negative 10x. Okay, so take my diagonals, add them up, minus x, minus 15. Boom. Now let's change colors here. F of x times h of x, so we're going to do a 3 by 2 here. So I'm going to do h of x on the top. It doesn't matter where we put these. 2x squared minus 3x plus 5. We get 2x plus 3. Get 4x to the third minus 6x squared. 10x, 15, negative 9x, 6x squared. So we get 4x to the third. Those are going to cancel out. That gives me a positive x, so I'd say plus x plus 15. Beautiful. Okay, and then g of x times h of x. We're going to do the same thing here. Okay, 2x squared minus 3x plus 5. Then we get g of x, which is 3x minus 5 here. So I get 6x to the third minus 9x squared plus 15x, negative 25, negative 15x, and then we get negative 10x squared. I have my diagonals there. So I have 6x to the third. That's going to be minus 19x squared. Notice that diagonal is going to negative 15x plus 15x is 0, minus 25. There's my 3. We did it pretty easy. I feel like that's a very organized way to simplify. If you have any questions about this lesson, you want to talk about it more, say, Ellis, that was whack, come and talk to me. I'm happy to help you out. Take it easy. Have a great day.